Hello. We're going to do another video. I just finished a bunch of that tooling stuff that you probably saw on the thing. And now it's time to work on an actual bike. Okay, this is going to be the X-Wing Starfighter. It is going to be a replacement for the Millennium Falcon. Okay, Millennium Falcon was a really good, or it still is, a really good mountain bike. Not a lot was wrong with it. Let's go down here. We can look at it. I had moved the head tube up to 67 degrees, and this proved to be so good, um, massively good. And I'm going to go steeper on the Starfighter. I'm going to go up to 68 degrees. We're generally trying to get head angles as or steeper, and now we're hunting for that right place, just like we hunted for the right front center. Now we're going to be hunting for the right head angle. And this is a trickier bike because it's a bigger hit bike, and bigger hit bikes tend to go down steep chutes, and in that type of environment, the head angle could affect how the suspension works at that critical moment. But of course, the head angle affects how the suspension works throughout the rest of the ride, and that's where we're getting the huge gains from the steeper head angles. And that's probably to the detriment of suspension action in a steep descent. But is that truly noticeable in the environments that I'm playing in? I'm not racing. I'm looking for overall performance on a bike ride, not just performance on one, let's say, downhill race run or enduro race run, where the conditions may be far more extreme than most of the ride would be. Um, so I'm looking for that. Um, Chainstay was looking pretty good. We're about at the minimum that we can do at the tire clearance. I'm going to bring the seat tube angle up just slightly more. When we change our seat tube angle to be steeper, we start putting more weight on our hand grips. Um, and for an old guy like me without a lot of upper body strength, that can be a problem. For younger guys, maybe it's not a problem. Also, I live in Northern California, not the Pacific Northwest, blah, blah, blah. But that steeper seat tube angle really has a great effect on just in and out of the saddle while you're climbing. You know, up and down, up and down. Every time you get out of the saddle, that's aided by having a steeper seat tube angle. So we want that in that environment. Problem is, during traverse and everything, puts more weight on the hand grips. So, blah. Another change that's happening. This was a 305 crank height, um, and the crank height's very good. But I'm going to be changing to shorter cranks. I'm going to give it a shot. I've been late to the party on mountain bikes. I switched to road bikes to a 167 and a half crank length from 172 and a half crank length recently. Now, old Rusty Joe over here, I've been on 175 for, forever, and I'm going to go down to 170. So it's not a big change, but it's a change. I'm hopefully moving in the right direction. We'll see. But that means that this 305 crank length can go down 5 millimeters, obviously, because we've opened up that space. The limiting factor, of course, being the bottom of the pedal. So we're going to bring that down 5 millimeters. The other real factor here is heel clearance. So I was already working on heel clearance in the Millennium Falcon era, but I've in the past year and a half, 2 years, Um, let's see, when was the Millennium Falcon done? This is when it's nice. 2003. So we're a year and a half. Okay. Um, I was working on heel clearance, but I didn't get quite as much as I very much could have. UDH was still kind of, a real thorn. Kind of gotten past a lot of that. So heel clearance, we're going to boost up. Everything else is going to be probably fairly traditional. Let's see, anything good here? Yeah, anyway. This is the older new style head tube. We've got a new style head tube. Okay, let's go to BikeCAD. Okay, so in BikeCAD we can see that head angle is changed to 68. Um, of course, now I've committed to horizontal centers. So I'm defining the bike in terms of rear center and front center horizontally to the ground. Um, because of that steep tube, the head tube angle, we've got this really low flop height, which is pretty cool. That is going to make this bike feel so much lighter on the trail. It really peps them up, and this is going to be quite a cool feeling, similar to like the M2F2. What was that, 69 or 68? I can't remember what the M2F2 was, but we're going to lighten up the front. Of course, this moves the head tube far more forward, and we're going to have far more extended rearward handlebars to replicate our riding position, which is really good. I'm really liking that riding position, that hand grip position, I should say. Yeah. Uh, Here's the effective seat tube angle, 76 degrees now. And that would be obviously a real seat tube angle of 71.9. Blah, blah, blah. Oh, okay, here's crank height is 300 now, down from 305 because of the crank length. But because of the crank length, now our saddle height is 5 millimeters higher. Because, of course, the bottom of the pedal at full extension is raised up 5 millimeters, so now the seat has to go up 5 millimeters. So we've got a bunch of those things. I just noticed a problem here. This is going to be a 92 symmetric, not an 89 symmetric. I have to fix that, but everything else here should be correct. I'm marking the short cranks. Yeah, pretty good. Balearic 160 is really nice. I should probably get in and service that soon. I don't know if it needs any tuning. They're so good now. Certainly at my weight. Okay, so different front and rear tires in the definition, of course. So 75 millimeter to 71 millimeter drop there. We're using up a third of the travel in this definition, or sorry, 30% travel in this definition. Cool. And of course, that seat tube, its position is defined by this 385 number. Now there's an angle, but then the distance or lateral position is defined by this. So this 385 is the maximum tire radius plus the anticipated tire gap to the rear of the seat tube. And then, of course, you'd just add half the seat tube diameter, and that defines where the seat tube is located. I like playing with BikeCAD for most of my fit because I'm getting my saddle position correct, because obviously the actual seat tube, even if you extend to the rails, doesn't exactly reflect where the center of the saddle is. So BikeCAD helps for that. Okay, let's go into SolidWorks now. So here's the bike in SolidWorks, and we get a lot more detail. Maybe we'll go front to back. That'll be cool. Okay, the new head tube. The new head tube's cool. I could reduce this diameter with a unitized type. I was doing the segmented style where I'd press them together, but that forced a 2-inch OD here. And by going to a single machined part, not only is it cheaper monetarily, but it shrinks this diameter. I think it was 1/8 of an inch or so, and that may seem like a small amount, but it adds up. Um, okay, just recently I got my head tube caps done. So here it's shown with the head tube cap, and hopefully later I'll get these spacers done because they connect into the binder really nice, and they kind of have this, I keep thinking Aztecs when I'm looking at the facets there, which, I don't know, that's kind of cool. Here we've got the similar handlebar style to the Millennium Falcon. On the crossbar, I'm actually moving it further away from the steerer tube so I can meet a little bit more tangent to these bent strut segments and a bit high. By doing it right up here just before the bend, it makes it probably a little easier in the fabrication process, and also it has that more BMX style where the crossbar's below the bend type of thing, which is, I don't know, I hesitate to want to be traditional, but it's something fairly familiar. But still, having a crossbar here is kind of nice. Okay, let's continue to move back. Well, we've of course got the head tube routing, which I think more people need to go to. It really helps out a lot. These guys here, you know, that's huge for external routing. And now here's the top tube. And this started with the road bikes. I finally got off my ass, and let's look at it. Is this it? There we go. So it's an oval top tube. That's cool. And they're butted. So we've got a butted oval top tube, and that makes effectively a 1-inch section from the side and like 1 1/4 on the top. You can see it's kind of like, it's pretty cool. I'm liking that. Hopefully, and this is going to be my first dirt bike with that. The two road bikes got it first. 1 3/4 down tube. This is a long tube, so we want to have something to support it, and that diameter is going to help. Okay, we come down here, and the Saurig style intersection of the seat tube. This is to maximize seat room, and while Ronen has his actual dropper extend into the down tube, I don't. I'm not that close. Let's change the transparency there. So you can see I have a router that goes to my external right to the underside, and that curves everything back up and extends underneath the down tube area there. This has worked out so well. I've only done minimal modifications to that over time, but you never know when something ends up being massively reworked. But for now, that's working out well, and it just gets brazed into place after construction. Yeah, it's got a little support there, but that way, the end of the seat dropper can come all the way down to here and still function well. Here, I'll do that. Now, of course, and people might not have gotten the full explanation of these supports here, when we connect the seat tube to the down tube up here, there's a significant amount of twisting force going through the frame. And typically when we have a seat tube connected here, the crank shell has something supporting it other than the down tube at a let's say a greater angle to spread that support out so that that bottom bracket isn't left to wrench so much. But if I didn't have these supports, that twisting would be focused in this region here. And we've seen pictures of bikes that, like with connections like this, that are failing in this area. And to mitigate that, I've got these cool, they're like a triangular cross-section printed piece that go in there, and they help support the bottom bracket from twisting so violently against the down tube and supporting itself on the seat tube, which is pretty cool. We get up here. You know, I've been doing these seat stay yokes for a long time, and the rationale for it is I got big fat legs, and when I'm riding, this area right in front of that yoke by the seat tube, my knee area goes in this area, and if I have anything but the bare minimum of material sticking out, it interferes with my body, and that's not good on a bike. We never want the body to be interfered with by the bike. That's I mean, if we have to explain my short head tubes, I'm trying to get my top tube as low as possible to get knee crossover, any space up here that I can get when I'm riding. And that extends back to here. I'm getting knee clearance. And also that's why it flattens right in that area. It's pointed on the inside to try to gain some strength from the triangulation. But this flatten is, I think it's like effectively a 1 1/8 diameter there to soften the blow against my body when it does interact there. But the clearance at this point is so good that, especially at my tire size, I think a big mistake people make with hardtails and short stays and things like that, you don't need a very big rear tire on a hardtail. I tend to use 61 millimeter rear tires. They're great. You can get them to roll fast, you can get them to hook up, but there's body clearance issues up here too. When you buzz your tire against your leg, that's not cool. And a reduction in tire width helps there. So there's a lot of huge gains with smaller or narrower tires. Real gains, especially if you low knob. You know, the front can be big pokey knobs and big tire, whatever you want to do, but the rear, tone that stuff down. It's going to help you roll. It's going to help you move around the bike. That's all good stuff. Okay, T47, we're kind of stuck with that because the industry loves stupid cranks. So I move forward with that. The chainstay yoke. Oh my goodness. Look at this sucker. I nerded out on this. I finally cracked through part of the way these struts work. Let's open this up separate. Okay, look at that. There is a lot going on here. Obviously, this is the money shot right here, where the chainring and the tire are closing everything up. But if you notice cross-sectionally, I have a huge area there by doing this drop stay and crossover. It's extremely rigid structure. If you look at the bottom, there's a lot of support for that side of the stay. If you've ever done flimsy stays, you know how bad it can get. This is a huge amount of clearance. I've also got like just bike clearance with this lower chamfer, and it goes all the way around, which is really cool. It's adding more clearance. I've got my routing there with the 2 different diameters because brake hose and derailleur hose are different. Fairly narrow support. That's cool. I've gone down to just a single internal support like that, just to make your I-beam. I call this the reach around from a drop stay perspective. If you notice the strut that goes up to the bottom bracket meeting tangent to it, Where it meets the yoke is as far to the rear generally as we can go. And that's a really nice way to do that because, for one, that area here that I said had the big cross section, it increases that cross section, which helps us. It's also going back to where you need it. Like if this came up to the front, well, we don't necessarily need it to be supported up there. That's just holding the two sides together. So we reach all the way to the back where the connection happens, and that's going to help support the stay tubes even more. I ended up with this giant facet here, and that's probably the thing I have a problem with the most, other than the flat bottom here. Now, let's just talk about this part here. To get rid of this big, massive section, when you look at it in the bike, I decided to cut out this area and make these into like, I think I called them flying buttresses when I was working on them. And that ends up producing this cutout type thing, which is pretty cool. I don't know. We're going to see how it looks aesthetically. But I still end up with this giant facet. I don't know. We'll see how that goes. Now the flat bottom, when you look at it from here, it looks really bad. You're like, oh, that's gross, it just doesn't seem right. But let's go back to the full model. You got to remember, especially when you're designing 3D printed parts, you have a lot of leeway on shape, and let's say you're looking at these parts. You're standing next to the bike and you're looking down. Okay, that's key. Or you're looking at it from the side. So down and from the side are the primary viewing angles of any of the parts. The only people that are going to look at the bike from this side are assemblers or technicians. So it can be flat there, and the thing is we're trying to support it, laterally here. So a flat section's actually better there. It meets the bottom bracket or the crank shell much better. And truly, when you're looking at it from above, you don't see it. Okay? That's also the rationale for the routing here. If you notice, that's shifted inboard, and that's because when you're looking at it from the top, it hides on this side, and while it's more proud on this side, there's a lot of tire and spoke and confusion in the way that kind of distracts from that, so you don't see it so much. So that's another little trick that we do to make the bikes look even better. Also, I mean, if you're just getting started, if you're looking for a dropper entry, the port, it goes behind the chainring. It doesn't go on the rear or the left-hand side of the seat tube. If you're coming in on the seat tube, the correct location is on the drive side behind the chainring. The chainring distracts from it. Suddenly, there's no more port entry, even though it's right there in plain sight. People don't see it. We have to play with the eyes when we're designing. Now, I don't do that here. This is the final routing path for the rear derailleur. I tend to use cable actuation on my bikes, and what's interesting is a routing from the inside of the stay to the outside, up and over, works out very good. It's one of the best routings I've encountered like that. Okay, now we're flat mount 160 with a 30.5 degree angle per SRAM specification, to post mount 180 per SRAM 60 degree specification. Those are the two specifications I think most people should use. And we have these special adapters because aren't any adapters in the marketplace. Um, Now, I mentioned heel clearance before. Let's go to a top view of this. Ugh, I hate that. Ugh. Okay, I gotta fix that one day. Okay, if we look down, let's look down on the bike. You can see how much this is tucked in. There's a little waggle in this chainstay, and I'm actually doing symmetrical tube sections here. I guess I played with more with this drive side tube coming inboard more because there was more room to do it. Um, and I'm working away from that because it just seemed to not make sense. If I was doing one, I should just do the other. Um, and over here, the the restriction is the rotor. So if we were to put a rear rotor in here, let's go do that so that everyone can see. We're going to unsuppress the rear rotor, and hopefully this comes out right. Oh, I have another caliper and rotor. Maybe that's the front one. I don't know. We're going to sit and spin. Here, I'll have a drink of coffee while we wait. My God, it's doing something. Okay, so of course we got the rear. Got the rear. Oh, and it's a mess. Let's do flat mount 60 to post mount. Where is it? 160, post mount 180, 1. There we go. So I guess I hadn't fixed that. It's still set up for a road bike right now in this assembly. But I thought I was just playing with it. Oh, okay, I know which assembly I'm in. Okay, anyway, we're fixed. We're back. So I could probably come in closer with these seat stays to that 180 rotor, but caliper's not aligned. Down here, when we look at the 180 rotor, that we're coming pretty darn close with our chainstay as it is. Now I could extend and go around, but I still can't get much narrower than how I am over here. So we're pretty restricted there. Also, this adapter, and this is why it's important to do a full assembly, this adapter, if I tucked this way in there and I played some crazy tricks, well, now my adapter is sticking out past the stay. If my adapter is sticking out past the stay, that's what I encounter first. And I'd rather hit the stay than the adapter. One, it's probably not going to lacerate me or feel really bad or tear into things. But I hopefully won't knock my my brake caliper out of alignment. So I kind of need to keep that a little bit shielded. So I have done that a bit. Okay. Now let's talk about the the dropout shape. Okay, so again, heel clearance is the big operator back here. If you notice, I do a little bit of waggle on the drive side, and I'm kind of restricted right here in terms of what I can do with the UDH, but I've minimized that. Over here, I've reduced the counter bore into the dropout for the axle. This axle's a little proud now, but that's in real use isn't that big of a deal. So I gain a bit of space in this area here because of that. And that's a lot more where my heel is interacting. Now, because I'm cutting into there, let's open up the file for this. This is the last part I was just working on. They all keep circling around. Because I'm actually cutting these down so close at the end, this is a very narrow section here. I can't remember if it's 13 millimeters wide or whatever it is. Here, let's measure how wide that is in fact. Uh, 15 millimeters. It's not crazy, but a lot of that isn't doing work. So anyway, and then it's got this massive cutout in it, which is brutal, and we have a path for wheel entry during loading and unloading, and a ramp into that to help. So we have, I mean, this is an old trick. We know this one. I guess on UDH side it doesn't matter anymore, but we use a loading ramp, so we get it wider and then ramp in. But because it's getting so narrow, I made this section here much broader to support that section, and it extends all the way into the brake caliper area here, and not as far on this side because these are printed at different lengths and stuff, and they have different clearance needs. The thing about dropouts and why this is this gets into multi-body part modeling and stuff. With 3D printing, we do a lot of Boolean functions, we do a lot of surfaces, but in particular with parts like dropouts, I've found it helps to do multi-body parts because there's certain things about dropouts that are very similar to each other that you want to have sameness, and other things that are different. A drive side and a non-drive side are different, but in this case, they meet the tubes in certain ways, or they have certain fillet sizes that I want consistent across the board, and this can really help me control all that stuff. But you can see that I've really broadened that connection up for that narrow section. This is our bleed screw. There's a set screw that goes in here. If you noticed, we're having a problem with 3D prints being permeable. This isn't just a problem for low-cost bike producer types like me, but even in high-tech type companies or fancy customers, gas permeability through prints is a thing. I show it in the M2F2 paint problem I had, where gas was permeating through a sealed section through the 3D print while it was in the powder coat oven. So now the whole rear end has a bleed through this hole that gets covered with either the UDH hanger or the T-type derailleur, and then I screw in and seal a set screw after. So that's hidden from view right there. And I just try to smooth things out. This area here is necessary to clear the chain and cogs and some stuff if you have a snafu with your drivetrain. Over here, let's see, are we done? Oh, this brake mount. Compare this brake mount connection to anybody else's. I contend that this is so much nicer. You could argue this bridge and connection. I kind of like that from a just brick shithouse perspective. It may not be required, but if you look at like how this works, here, let's go to the model again, and we can change our transparency. If we look in there, now granted these bolts are long and probably heavier than they need to be, but such is life. We're trying to build strength into this setup, but if you look there, there's a lot of minimization of what's needed and what's supporting what, and how much we're just cutting our stay up. You can see the set screw in place over here and the bit of material for it. And let's get to, I think, the last stop on this trip. People will know that I was doing um, hanger modifications to UDH where I trim the fin. And that's been working fine and everything like that, and I like it, and it was helping for a while with this seat stay connection. But this summer we had the Made bike show, and boy, the Australians showed up for that. Wow, last year it was Canadians, this year it's Australians. Um, but then one of our local fancy bike shops above category had their own mini show afterwards, and that was pretty much all Australians and um, is it Peruvians with what's that company with the fancy paint jobs? Scarab? Are they Peruvian or what? Anyway, not Peruvian. Yeah, maybe Peru. Anyway, whatever. And of course, Rob English. But I was talking with Daryl. Is it Daryl Baum, who does Baum bikes out of Australia? And of course, he builds a lot more high end bicycles with fancy parts and everything like that than I do. Uh, he's obviously a commercial business, and that's their job. That's their goal, is to do that. Um, and we were talking about this area here, and he said that the new SRAM 13 speed drivetrains, the essentially road slash all road one by stuff, really digs into this area here, and that I should be very careful given that drivetrain coming up. Well, the 12 speed worked fine with this fin cut off and using some space. You know, I don't know. I figured he's a smart guy and knows what he's talking about. I'm going to listen to him. And I decided I'm going to go back to the fin to drop out and um, clear up that space for the 13 speed, because Lord knows it probably will be coming to mountain bike. We need to take delicate, barely functional drivetrains and add more gears and make them more delicate. That makes sense, right? Who wants a solid drivetrain, right? But anyway, so the fins are back. Um, and what else can we show here? We've got our thing here, our data plate showing all our cool stuff. No real change in the strappy doodles for the water bottles, and we're doing titanium ends there. Let's go back to this guy here. So when I post prints, I'm trying to clarify a little bit more now. I had to regenerate this. I'm having trouble. SolidWorks drawing dimensions are just a nightmare these days, and I'm having to redo how I do models and dimensioning for a 2D drawing. But if you see these numbers here, the crank axis normal, and then rear wheel trail, and rear axle normal. So that's marking a position. If you had a right angle from your head tube to your rear axle, that's where it intersects with your crank axis normal. That's where your crank axis would intersect with a normal line. And these numbers come up when you're doing dynamic systems, when you have head angle changing and stuff like that. If you know these values, they don't change, and you can be accurately predictive about conditions following by referencing those rather than some others. rear wheel trail, that's where the rear wheel trail will intersect um, the frame. So when we get into our fundamental drawing for the bike, we know where that position is. And if we're getting into real just dynamics or kinematic type things, we know where that location is because that's important. Um, there we go. Hopefully everything's marked here well. Okay, folks. So that is my thing. I hope this turns out well. I expect to be ordering prints in the next couple days. We're really at the late stages here. That's where a lot of the real changes start happening in shapes of things. I significantly improved this angle here of the top of this, so I'm not leaving this guy out in the cold. That was this morning. I woke up at 4 to do that. So yeah, I just wanted to just go through the whole thing, share what happens in all this. Okay, thanks for watching this.